Welcome to qnawire.
For this problem, we will firstly write down the gravitational force law. So the force between two massive objects is equal to G, the gravitational constant, times capital M, which is the mass of the Earth in this case, times little m, the mass of the Moon, over the square of the separation between them, r squared. And we also know that since the motion of the Moon is centripetal, the force, which we get from Newton's second law, m an, where an is the normal component of the acceleration, is equal to m times v squared over r, where v is the velocity of the orbit and r, again, is the separation from the Earth. So if we equate these two expressions for force, we see that g m over r squared is equal to m v squared over r. And so v squared is equal to g m over r, so little m's cancel. But we also know that g times m is equal to the gravitational acceleration on Earth times the Earth's radius squared. So therefore, we can write v squared as g r squared over r, or v is equal to r times the square root of g over little r. We also know that for one orbit, the period of the orbit tau is equal to 2 pi r over v, which is simply 2 pi r over our expression for v, which is r times the square root of g over little r. So from here, we can actually write an expression for the separation between the Moon and the Earth. If you rearrange this equation, we get that r is equal to g times tau squared times r squared all over 4 pi squared, and this is all to the power 1 over 3. So rearranging, we now have an expression for the separation between the Earth and the Moon. We also know that the period of the orbit of the Moon is 27.3 days. And so we'll convert this to seconds. So this becomes 2.35872 times 10 to the 6 seconds. And the radius of the Earth, big R, is approximately 3,960 miles. So this is 20.9088 times 10 to the 6 in feet. So the first thing we'll do is calculate the value for R in SI units. So in SI units, R is equal to, and we use the equation above, G, which is 9.81 meters per square second, times 2.35872 times 10 to the 6 seconds, and that's squared, multiplied by the radius of the Earth, which is 6.37 times 10 to the 6, and that's in meters, all over 4 pi squared, and this is all to the power of 1/3, the cube root of all this. Hence we get the separation to be 382.81 times 10 to the 6 meters. So that's little r, the separation between the Earth and the Moon. In US customary units, we'll perform this calculation again, and we get that r is equal to, g in this case is 32.2 feet per square second. That's the acceleration due to gravity on the Earth. And that's multiplied by tau, which again in seconds is 2.35872 times 10 to the 6 seconds squared, multiplied by the radius of the Earth in feet, which is 20.9088 times 10 to the 6 feet squared. And this is all over 4 pi squared. And the entire thing is to the power 1/3, the cube root. Hence we get the separation between the Earth and the Moon in US units to be 1256.52 times 10 to the 6 feet. And hence this is 238 times 10 to the power 3 miles.